In this video, we will see how can we apply the knowledge we gained by this time from our previous chapter, differentiation. How can we apply calculus or that derivatives in order to understand some real life problems, which is application of differential calculus. The main target will be what? If you are given a nonlinear cost function. In chapter 1, we discussed linear cost function that was like this: y equal mx plus c, y equal mx plus c. This is a linear cost function, but in real life, cost function most of the cases will be nonlinear. For example, this is a cubic function, and the graph of a linear function we know is straight line. However, the graph of a quadratic function like this, ax square plus bx plus c, this is a quadratic function. The graph of a quadratic function will be either concave down or concave up. This is called concave down, C-O-N-C-A-V-E, concave down or concave up, depending on the coefficient of x square. If coefficient of x square is positive, then it will be concave up. If coefficient x square is negative, it will be concave down. And a cubic function like this, y equal to let's say y equal to ax cube plus bx square plus cx plus d. This is a cubic function, and the graph of a cubic function will be like this. There should be of two peaks, and in a quadratic equation or quadratic function, there is a single peak. There is a single peak, and in a linear function, there is no peak. There is no nonlinearity. So if an equation is like fourth degree equation, like y equal to ax to the power 4 plus bx cube plus cx square plus dx plus e. This is a biquadratic equation or fourth degree equation. So the graph of this fourth degree equation will be like this. There should be how many peaks? 3 peaks. 1, 2, 3. So the number of peaks depends on the degree of the function. If function is of fourth degree, then there are 3 peaks. If it is third degree, then there are 2 peaks. So in these types of nonlinear cost function, we want to find maximum point. This is the maximum point, and this is the minimum point of this function. So we want to calculate maximum point and minimum point of a given function. If it is a cost function, then we try to find the minimum point, minimum value of y. However, if it is a profit function, we are looking for maximum profit, maximum point, or maximum value of y. So depending on your question, you can calculate either maximum point or minimum point or both. So this is our target. What is our main target in this chapter? In this chapter, we are looking for 4 points. Number 1, maximum point. Number 2, minimum point. Number 3, inflection point. Which we denote by IP, inflection point. Maximum point we can denote by only max, or minimum point we can denote by only mean. Minimum point, maximum point, inflection point, and the fourth one is stationary inflection point. Stationary inflection point, or SIP. So this is our main target, to find maximum point, minimum point, inflection point, and stationary inflection point of a given nonlinear function, like this. So the question is, how can we do that? First, what is a stationary point? Maximum point as well as minimum point is known as stationary point, and at those point, maximum point or minimum point, the first derivative equal to 0. First derivative f prime x equal to 0. Why? Because the tangent line is parallel to the horizontal axis or x-axis. Tangent line is parallel to the horizontal axis at the maximum point as well as minimum point. If you draw a tangent line, then the slope of this tangent line is f prime x, we know, and the slope of this tangent line is 0 since it is parallel to the x-axis. However, the slope before this point, like here, the first derivative is positive because the tangent line is an increasing line, and after this point the first derivative is negative. So from here to this peak, first derivative is positive. From this peak to this peak, first derivative is negative since this is a decreasing line, and after that peak again first derivative is positive. So what is a stationary point? A stationary point is a point on the curve where first derivative equal to 0. This is important to note, that a stationary point is a point where first derivative equal to 0, and a function is said to be increasing function, like from here to this peak. This is increasing function because first derivative is positive, and from this peak to this peak the curve is decreasing, or the function is decreasing function. Fx is decreasing function because first derivative is negative. And there is a point, I said inflection point. What is inflection point? Inflection point is one where the curve changes concavity. Like I said, this is concave down, this curve concave down, and this one concave up. So there is a point on this curve, like this point, where the curve changes concavity. That's why this is called inflection point. How you understand that it changes concavity? You see, from here to here the curve is concave down, and from here to here the curve is concave up. So at this point the curve changes concavity. Therefore this point is called inflection point. So we understand maximum point where we will get maximum value of y, and minimum point where we will get minimum value of y, and at those 2 points first derivative 0. However, at the inflection point where the curve changes concavity, first derivative is negative here, so I can say first derivative is not 0 at this point. And the fourth point, I said stationary inflection point. Stationary inflection point is a point, the point is a stationary point as well as inflection point. This point is a stationary point as well as inflection point. So what does it mean? It means here first derivative will be 0 as well as the curve will change concavity at this point. For example, if you sketch y equal to x cube, you see the curve at 0. At 0, the curve is, this part is concave down and this part is concave up. So this is a graph which is for y equal to x cube, and this is x-axis, this is y-axis. So here x equal to 0 is a stationary point, because at this point first derivative equal to 0. First derivative equal 3x square, which is equal 0, gives us x equal to 0. So x equal to 0 is a point where first derivative equal to 0. And here the curve changes concavity. You see this part concave down and this part concave up. So this point is known as SIP, stationary inflection point. So by this time we understand 4 points. A point where y has maximum value is called maximum point. A point on the curve where y has minimum value is called minimum point. And the point where the curve changes concavity is called inflection point. And a point where first derivative equal to 0 as well as the curve changes concavity is called SIP, stationary inflection point. These 4 points we are looking for first for a function, for a nonlinear function like this. So let me discuss these things again in this graph. At the maximum point, I said at the maximum point first derivative equal to 0. In this figure we want to know the mathematical condition to understand whether the point is a maximum point or minimum point or inflection point or a stationary inflection point. Inflection point or stationary inflection point. So the first condition is, for this point first derivative is 0. For the maximum point first derivative will be 0, and for the minimum point first derivative will be again 0. For the inflection point first derivative is negative, either negative or positive. If it is in this part, then it will be positive. So first derivative not 0. Now you understand that this point is a stationary point and this point is a stationary point, but you don't know whether this point is a maximum point or minimum point. To know this, we need to calculate second derivative. If second derivative at this point, if second derivative at this point means at the corresponding x, let's say x equal to a, and here you will get another x value, let's say x equal to b. So we understand that there are two stationary points. One is at x equal to a and one is at x equal to b, since first derivative equal to 0. And by setting first derivative equal to 0, if we solve this equation, we will get two x values, let's say a and b. It means there are two stationary points. One is at x equal to a and another one is at x equal to b. Now we want to check whether the stationary point is a maximum point or minimum point. This one we will understand from the second derivative. If second derivative at a is negative, then there is a maximum point. So the condition for maximum point is first derivative will be 0, second derivative negative. And first derivative will be 0, second derivative is positive, then the point is a minimum point. These are the mathematical conditions for minimum point, and these are the mathematical conditions for maximum point. Max for mean. And for the inflection point, first derivative not 0, second derivative will be 0, as well as third derivative should be not 0. So from these three mathematical condition, you will confirm that the point is a inflection point. And for the SIP, like this, for this SIP, stationary inflection point, this is a stationary inflection point, and the mathematical conditions are first derivative will be 0, second derivative will be again 0, and third derivative is not 0. If these conditions holds true for this point, then we can confirm that this point is this point is a SIP or a stationary inflection point. This point is a SIP or a stationary inflection point. So let me review again. For the maximum point, you need to confirm that second derivative is negative, and for the minimum point, second derivative is positive. However, if second derivative is 0, then you need to move forward to the third derivative. If third derivative not 0, then this is a SIP. And now for the IP, you don't need to think about first derivative. Just from the second derivative, you need to calculate x values. By setting second derivative equal to 0, you need to calculate your x, and this x will be the location of inflection point. Where the inflection point is located, this x will inform us that things, and if you put this x value in the given function, you will get the y coordinate of this point. Okay, the x coordinate of maximum point if a, then y coordinate of maximum point will be fa. X coordinate of minimum point if b, then y coordinate of minimum point will be fb, and this fb you will get from the given function. If you put b in the given function, you will get y coordinate. Let's say inflection point is at x equal to c, and this c you will get by setting second derivative equal to 0. So the x coordinate of inflection point is c, y coordinate of inflection point will be fc. So fa is the maximum value of y. What is the maximum value of y? Y max. From here we can decide that y max, maximum value of y, is equal fa at x equal to a. Y mean, minimum value of y is fb, which is at x equal to b. If your question tells you to calculate maximum value of y, then you need to calculate fa. If your question tells you to calculate minimum value of y, then you need to calculate fb. However, if your question tells you to calculate maximum point, then this is the maximum point. And if your question tells you to calculate minimum point, then this is the minimum point. So the method I have explained here is known as second derivative test. This is the second derivative test in order to calculate maximum point, minimum point, inflection point and stationary inflection point. And there is another derivative test which is called first derivative test. We can also calculate maximum point, minimum point, inflection point and stationary inflection point by first derivative test. That I will explain later. So these are the basic discussion in this chapter. If you want to solve all the given problems that I will discuss in our next video. Thank you very much.